we studied Boyle's law. According to Boyle's law, at constant temperature, fixed mass of gas pressure is inversely proportional to its volume. P inversely proportional to V at constant temperature. PV equal to constant, P1 V1 equal to P2 V2. And one more important conclusion from Boyle's law, P directly proportional to density of gas at constant temperature. So Boyle's law applicable when mass of gas is fixed and temperature of the gas also constant. Then only we should apply Boyle's law. The graphs between pressure and volume, the graphs are called isotherms. Okay. And next, very important second law is Charles' law. Yes. What is Charles' law? Charles' law, it is temperature and volume relationship. He did many experiments on temperature and volume at constant pressure, and volume of gas also constant. I mean, mass of gas also constant. In his experiment, he took 273 ml of gas at 0 degree Celsius. He observed when temperature of this gas increased by 1 degree, the volume of gas increased by 1 ml, 274 ml. By increasing 2 degrees, volume of this gas increased by 2 ml. 10 degrees, 10 ml. By decreasing 1 degree, minus 1 degree, volume of this gas decreased by 1 ml, 272 ml. By decreasing minus 10 degrees, it is 263 ml. Based on this experiment, he concluded that at constant pressure, fixed mass of gas, volume is directly proportional to temperature. That is simply Charles' law. Okay, so write down statement regarding Charles' law. At constant pressure, fixed mass of a gas, volume increases or decreases by 1 by 273 of its volume at 0 degrees Celsius for each degree rise or fall of temperature. So how can we express mathematically initial volume, let's say V naught. No, no, VI. Let's say VI, initial volume. By changing temperature, the final volume is VF. And V final must be equal to V initial plus V initial into T by 273.15. Students, exactly it is not 273, it is 273.15. But for calculation purpose, we are taking 273. Okay. Yes, this is the mathematical expression for this Charles law. Let's say 273, it is initial volume. By changing 5 degrees, by increasing 5 degrees Celsius, what is the new volume? New volume 273 plus 5, 278 ml must be. Okay. So apply this formula. V initial 273 ml plus V initial 273, temperature increased by 5 degrees by 273. I'm taking 273 for simplification. So 273, 273 cancel. 273 plus 5, 278. That's why the formula is V final is equal to V initial plus V initial into T by 273.15. Are you getting? You can take minus 5. Even in case of minus 5, here minus 273 minus 5, then you will get 268. So this formula we can use for Charles law representation. V final equal to V initial plus V initial into T by 273.15. Further simplification of this formula, V initial is constant. So common 1 plus T by 273.15. Further simplification, V final equal to Vi into 273.15 plus T by 273.15. 273.15, he considered 273.15, he considered it is 0 degrees Celsius, and he denoted this 273.15 equal to 0 degrees Celsius. This 273, he introduced new scale, that is Kelvin K. Okay, so V final equal to V initial 273 plus this T in degree Celsius. So Kelvin plus this one new temperature, that is T final, by 273.15, it is a temperature initial. So finally we can write V final by V initial equal to T final by T initial. From this equation we can say volume is directly proportional to temperature. But this temperature must be in Kelvin. This temperature must be in Kelvin, because he represented this 273 as a new scale, Kelvin. Are you getting my point, students? Say yes or no. Are you getting or not? Yes. Very easy, Nana. 273.15 he considered as a new scale, that is TI. By adding Celsius to the 273.15, that is, if you add 1 degree, that is 274.15, that is in Kelvin scale. Finally, we can say volume is directly proportional to temperature. That's why at constant pressure, fixed mass of gas volume increases or decreases by 1 by 273.15 of its volume at 0 degrees Celsius for each degree rise or fall of temperature. Yes, completed. Okay. So we can write another simple definition for Charles law. At constant pressure, fixed mass of gas volume is direct directly proportional to absolute temperature or Kelvin temperature. You must consider temperature in Kelvin scale only. If you take degree Celsius in centigrade, the answer will be wrong. So volume is directly proportional to temperature. The temperature scale must be Kelvin at constant pressure. Very, very important. So V directly proportional to T. Proportionality constant V equal to KT, where K is proportionality constant. From this we can say V by T equal to K. From this we can say V1 by T1 equal to V2 by T2. or we can say from this V1 by V2 equal to T1 by T2. The ratio of volume and temperature of gas at constant pressure is constant. And you can represent Charles' law even by using this definition. At constant pressure, fixed mass of gas, ratio of its volume and temperature is constant. From this, we can say V1 by T1 equal to V2 by T2. The students completed. Right. And one important conclusion from Charles' law, very important conclusion, V final equal to V initial into 273.15 plus T by 273.15. If you decrease temperature by 1 degree, 1 degree, 1 degree, 1 degree, let's say temperature minus 273.15 degrees, then what is the V final? V final equal to V initial into 273.15 minus 273.15 by 273.15. 273.15 minus 273.15 completely zero. So finally, V final is zero. What is V final is equal to zero? At 273.15 degrees Celsius, the volume of gas is zero. So one important conclusion, no gas can be as a gas at 273.15 degrees Celsius, or it is called 0 Kelvin. Am I correct? Because Kelvin scale is 273.15 plus T. If you add this Celsius, then you will get 0 Kelvin. One important conclusion, at 0 Kelvin, any kind of substance should not be in gaseous form. Should not be in gaseous form. Reason, if you decrease further temperature, let's say minus 274 degree Celsius, then what will happen? V final 273 minus 274. So V final, you will get negative value. Volume negative value, meaningless. Are you getting my point? If you take less than minus 273 273 degrees Celsius, you will get volume of gas is negative value, because this value is great. It is minus 274, then it is minus 1. V final is negative, volume is meaningless. So less than 273, impossible. That is the final temperature for the any kind of gas. So this 0 degree Kelvin is called absolute temperature. Please remember this point. What is absolute temperature? The temperature at which all gases are liquefied or solidified. That is called absolute temperature. That is 0 Kelvin minus 273.15 degrees Celsius. Students understood my point? It's completed this. Next, graphs for Charles law. Volume versus temperature. Equation is V equal to KT. It's like a Y equal to mx. This temperature must be in Kelvin. If you take degree centigrade, that is wrong. So it is 0 Kelvin. 0 Kelvin volume of gas is 0. So the gas volume increases, temperature also increases. Yes, Abhinash, I'm talking about gas. Gas volume at zero Kelvin is 0. I'm not talking about liquids and solids. I'm talking about gases. Charles law, Boyle's law applicable to gases only, not for liquids and solids. Gas laws only applicable to gases. I'm saying gas volume is 0. Okay. So this is the graph for volume and temperature. It is at constant pressure. At constant pressure, the obtained graphs are called isobars. What? Isobars. Isotherms for temperature, isobars for constant pressure. Next, V by T, VRT. V by T at any volume, at any temperature is constant. So this graph will be like this. Next, V versus 1 by T or T versus 1 by V. V increases, 1 by T decreases. V decreases, 1 by T increases. So the graph will be like this. And another important graph is it is V volume, it is temperature in degree Celsius, not in Kelvin. It is 0 degrees Celsius, 100 degrees, 200 degrees, 300 degrees, 400 degrees, so on. Minus 100, minus 200. Here, this point is minus 273.15 degrees Celsius. Okay, so it is a straight line, students. It is a straight line because v equal to kt. It is like y equal to mx. So exactly, it is not bending. It is not bending. These are completely straight lines. Proportionality. Yes, completed. Next, v by t equal to constant. Apply logarithms. Log v minus log t equal to log k. We can write log v equal to log t plus log k. It's like a y equal to mx plus c. If you draw a graph between log t and log v, you're getting positive slope. So the graph will be like this with a positive slope. Right. This is about Charles' law. One question based on Charles' law. It is desired to increase the volume of 80 ml of gas by 20 percentage without changing pressure. To what temperature the gas be heated if its initial temperature is 100 degree Celsius. Shashank, wrong answer. Abhinash, wrong answer. Likith Naidu, wrong answer. Okay, very easy question. It is desired to increase volume of 80 ml of gas by 20 percentage. Okay, initial volume is 80 ml. V final must be 20% increase. So 80 ml plus 20% increase in 80 ml. 80 into 20% in 80. V1 value 80, T1 value 298, V2 value 96, and T2 value we don't know. From this, T2 is 96 into 298 by 80, and this value is 275.6 Kelvin. If you do 275.6 minus 273 in centigrade, 84 degrees Celsius. In question they said volume of 80 ml of gas, it is desired to increase the volume of 80 ml of gas by 20 percentage. So initially is 80, we should increase the gas volume by 20 percentage. 20 percentage in 80, 16, add 80 plus 16. So total, according to the question, we should increase volume of gas as 96. Students understood? Okay, one more question is,
Sir, calculation mistake is there, sir. 357, sir. 357.6, sir.